Hey guys, and today I'm going to show you how we can find the graph of the function f of x is equal to sine of x plus cosine of x and all that squared. This looks like a really tough graph, honestly, because we don't know how to graph is y equals sine x plus cos x, let alone that squared. But we can perhaps use the identity that x plus y squared is the same as x plus y times x plus y, which is the same as x squared plus 2xy plus y squared. Let's apply that here, and we will get y equals sine squared x, f of x, sine squared x, plus 2 times sine of x, cosine of x, plus cosine of x squared, or cosine squared x. We can rearrange the terms here, and once we do that, we'll notice two important trigonometric identities. So this can actually simplify to be 1, which is a famous Pythagorean identity. This is less well known, however it can still be easily simplified. This is the same as sine of 2x. So now f of x is actually the exact same as sine of 2x plus 1, which we can graph very simply actually, because we know that our period is going to be pi divided by this, 2 pi divided by this. So the period will be 2 pi over 2, or pi. Our vertical shift will be dictated by this term, so it will be 1 up, and our amplitude, there's an implied 1 here, the absolute value of this. So absolute value of 1, our amplitude is just 1. Okay, and now we're ready to draw our graph. And actually, when we make the gradations for the graph, we're going to want to think carefully, because each period for sine and cosine graphs have 4 distinct parts which are equal in length. We can divide our period by 4 to get correct gradations on the axes. Now it's worth noting that you don't have to use these, but these make graphing the function a lot simpler. So you'll see that I have pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, which is pi. And now we have to take note of our vertical shift, which is 1 up. So our midline, which is normally at y equals 0, moves to y equals 1. So because there's no horizontal shift, what was our 0 before is now at 0, 1. And these, is now at 0, 1. And now we can begin our graph by using conventional properties of the sine function with period pi, and then draw it in. And you notice that each quarter period we get either the intersection with the midline or a max or a min. And because there's no negative or any reflection here, it's going to look it's going to look almost identical to the standard sine function y equals sine of x. Thanks.